Welcome to Cheenta Statistics and Data Science. Today we are going to solve this problem from ISI Mstat 2021, problem 21 from the PSA section. The problem says that the mean and the variance of a set of observations are 10 and 25 respectively. When two new observations are included in the set, both the mean and the variance remain the same. Which of the following statement is correct? So there are four options. The two new observations are both 10, two new observations are 20 and 0. The two new observations cannot be uniquely determined unless the number of observations are known, and the two new observations are 15 and 5. So there are four options we have to consider. So we don't know the number of observations, so let x1, x2 up to xn be the initial observations. Therefore, the mean mu is equals to 1 by n summation xi running from 1 to n, that is given 10, and the variance sigma square 1 by n summation xi square running from 1 to n minus the mean mu square is equals to 25. Therefore, from here, from this one, we get that summation xi running from 1 to n is 10n, and from here, since mu is known, right, it's 10, so here summation xi square is 125n. This is going to be needed later. Now, let the two new observations be xn plus 1 and xn plus 2. Right? Now, after these two observations are added into the set, the mean and variance still remain the same. So the new mean mu prime be 1 by n plus 2, right? Now it is n plus 2 observations, so 1 by n plus 2 summation I running from 1 to n plus 2, not n. So here's the mistake that some of us might do. So we have to consider that there are n plus 2 observations now, two extra observations. So this is again 10, since the mean and the variance remain the same, and the variance is 1 by n plus 2 times summation xi square I running from 1 to n plus 2 minus mu prime square. Again, this is 25. Now, from this particular equation A, we have summation xi I running from 1 to n plus 2. It's 10 times n plus 2, right? Just taking this n plus 2 term here on the RHS. Now, this can be splitted out as summation xi I running from 1 to n plus xn plus 1 plus xn plus 2 is equals to 10n plus 20. Now, this part is all we already know this one. This here. So, replacing this by 10n, we have 10n plus xn plus 1 plus xn plus 2 is equals to 10n plus 20. That means xn plus 1 plus xn plus 2 is equals to 20, right? We know the sum of the two unknown observations. From B, again, from this equation, this one, summation xi square I running from 1 to n plus 2 is 125 times n plus 2. Again, splitting out summation xi square I running from 1 to n plus xn plus 1 square plus xn plus 2 square is equals to 125n plus 250. This one again comes from here. Summation xi square running from 1 to n, it's 125n. So 125n plus xn plus 1 square plus xn plus 2 square is equals to 125n plus 250. Therefore, xn plus 2 square plus xn plus 1 square is equals to 250. So I've got these two equations. This one, the sum of their squares, and the sum. From here, let us just square this equation. This equation 1, we have xn plus 1 square plus xn plus 2 square plus 2 xn plus 1 into xn plus 2 is equals to 400, right? Just squaring this equation. This one you already know, this is 250. From this one, from this equation, we already know that. So xn plus 1 times xn plus 2 is 75. So using this and the original sum, this one, this equation 1 and equation 3, we have this quadratic equation, which can very easily be solved. Xn plus 1 square minus 20 times xn plus 1 plus 75. This is the solution to this quadratic equation is 5 and 15. So if xn plus 1 is 5, then xn plus 2 is 15, because the sum is 20, right? Again, if xn plus 1 is 15, then xn plus 2 is 5 again, because obviously the sum is 20. We know that the sum is 20. Therefore, the new observations are 5 and 15. That is the answer. It's a very, very easy problem. So yeah, you only needed to a very algebraic calculations for that and nothing else. Very easy problem. So yeah, here it is solved. It's a very easy problem. So see you till next time.